On this lesson, we will talk about the volume of prisms and pyramids. So let's start by having a visual interpretation of what a prism is. So here is what we're going to call a prism. And a prism, it's a three-dimensional figure where the bottom section is essentially the same as the upper section. So whatever polynomial that you do have on the bottom section, which is the base, if you want to call it that way, should be equivalent to the upper section. Now, there are some vocabulary words that go with a prism, and those are the altitude, which is essentially the distance between the upper and the bottom section, the lateral edges, which is just the sides of the prism, but not so much the sides, but more about the lines that connect the upper and the bottom section, and the lateral face, which is the actual sides of the prism. So any prism, it's a figure where the upper section it's equivalent to the bottom section, and we're going to refer to as the lateral edges as just the sides that actually connect the bottom and the upper. And the lateral face are the actual sizes or the actual lateral faces of this prism. Now we're going to be discussing two types of prism. The first one is a rectangular prism. In this case, we have an illustration of a right rectangular prism, but basically a rectangular prism is any prism, which notice that this fits the definition of a prism. The bottom section is equivalent to the upper section. They are connected by lines. And what's so important about a rectangular prism is that the connection of the upper and the bottom sections are going to be by some kind of perpendicular lines. So very important here. It's a prism where the lateral edges are going to be perpendicular to the upper and the bottom section. Now, an oblique prism, which in this case we have an illustration of an oblique pentagon prism, but in general, an oblique prism is any prism that is tilted in some way. So notice that here we have a straight prism. We can call that a rectangular prism. But if your prism is tilted, we call that an oblique prism. And now we're going to be discussing more into details in future lessons about how can we exactly find the volume of oblique prisms in a lesson that we're going to discuss in Cavalier's principle. So when we start discussing Cavalier's principle in the future, we're going to take in consideration those prisms that are oblique. But for now, we're going to state just the formulas and we're going to apply them. So the volume of a right prism is equal to the area of the base times the height of the prism. So what does this mean? So if we have any prism, let's take in consideration this prism right here. The way that we can define the volume of this prism is to first identify the area of the base. So if we're able to find the area of the base, which we're going to refer to this as just upper B. So if we get the area of the base and then we multiply by the height of this prism, if we multiply those two, we're just going to get the volume of the prism. And the way that I want for you to think about it is if we're able to define the area of the base, if we stack a lot of those bases, we're essentially just going to be making a right stack. And how many stacks are we going to have? Well, that's the height. So this is how we're going to be defining the volume of a right prism. We're just going to find the area of the base, and then we're just going to multiply by the height of this prism. Now, the second figure that we're going to be discussing is a pyramid. And now a pyramid, it's created whenever we have some kind of a polygon. It can be any polygon. So if we take a look at this polygon, and whenever our edges if we get the edges or the vertices of this polygon and we say that they meet at a point, at some point that is upper to this base, if we connect all the vertices from a base to a point, notice that what we create is a pyramid. Now, this point where those vertices are connected, it's what we refer to as the vertex. And we're going to call the base as being, well, the base of the pyramid. Now, very important that the height, again, in order for us to find the height, there always has to be a height. It's always represented as a vertical line. So height, it's a perpendicular line to the base. So it's a vertical line, but it's a vertical line that must be perpendicular to the base. And the name that we give to this line is the altitude of the pyramid. Now, a more specific example of a pyramid, because this is just the general case of a pyramid, it's whenever we have some kind of a base and we connect all the vertices to a single point, we create a pyramid. But now, a regular pyramid, it's a pyramid where the base, it's a regular polygon. So notice there's two big differences between just a pyramid and the regular pyramid. The first one is, if we take a look at the base doesn't have to be a regular polygon in a pyramid. Now, for us to call it a regular pyramid, then the base must be regular. And remember what a regular polygon is. A regular polygon is any polygon where all the sides and all the interior angles are congruent to each other. So we're saying that for any regular pyramid, the base must be of a regular polygon. Now, we almost use the same vocabulary that we use for a prism. The lateral edges are congruent. And why is that? Well, here we can see the lateral edges. So anytime we have a regular pyramid, we're also going to know that the lateral edges, which again, it is the lines that connect the vertice to the point of interest, here where all the vertices are connected. So all these lines that I'm drawing here, which is the vertices, they're all going to be congruent. And this is only true for a regular pyramid. Now, if all these lines are congruent, then notice that what we have created for the lateral faces are just going to be isosceles triangles. Because if we're saying that this lateral edge is congruent to this lateral edge, then therefore, all we have done here is we have created an isosceles triangle. So for any regular pyramid, the lateral faces are always going to be an isosceles triangle. And here we have two types of heights, if you want to call it. The first one is the height of the lateral face. And let me erase this because I feel like it's already overwhelming. So let me just erase this. So we're still talking about the same regular pyramid. So, okay, so that's gone. The height of the lateral face, it's called the slant height. In other words, the height of this lateral face. Now notice that this height, or L, is not exactly the height of the pyramid, but this is just the height of the side of the pyramid, which we're stating to be an isosceles triangle. So this is very important. This is something that students get confused here. Now, when we talk about the height of the pyramid, we're not just talking about the length of the height of the side of the pyramid. That's what we refer to as the slant height of the pyramid. Because remember that in order for us to measure the height of the actual pyramid, we need to use a perpendicular line. So in this case, the height of the pyramid is actually h. L is just for the height of the side of the pyramid, and h is the actual height of the pyramid. And we're going to refer to that as just the altitude. And notice that the altitude always meets the base at the center, which is O. So this altitude, If we're talking about a regular pyramid, this altitude, it's always going to meet at the middle or at the center. Oh, so this is just the vocabulary that we're going to be using throughout our lesson. But the main point here is the volume. And the volume of any pyramid, so the volume of the pyramid, it is going to be equal to 1/3 of the area of the base times the height. So the volume of a pyramid is going to be 1/3 times the area of the base times the height. So the way that we're going to define in the area, again, just to give you a visual representation of what's going on here, to find the area of any pyramid, we're going to concentrate on just the base. So if we're able to identify the base, and more importantly, if we're able to find the area of this base, if we're able to find the area of this base, okay, so if we're able to find the area of this base and we multiply this by the height, I guess it's already covered, but if we are able to find the height, that's all we need. So if we find the area of the base and we multiply it by the height times 1/3, then that is equivalent to the pyramid. And just by the way, because notice that B times H, this is the formula that we would use for the volume of a prism. So what we're saying here is that the volume of a pyramid, it's always going to be equal to 1/3 of the volume of a prism. So what we're trying to say here, or a relationship between a pyramid and a prism, is that we can always fit 3 pyramids in a prism. And that's something that we're going to be looking at in the future. But just by looking at the way that we define this formula, for any prism, the volume, it's always going to be equal to base times height, or the area of the base times the height. And for a pyramid, it's always going to be equal to 1/3 of the base times the height. So what this is saying is that we can fit 3 prisms, we can fit 3 pyramids into 1 prism. And we're going to take a look at that relationship in the future. But this is just to give you a heads up of where we're heading now. So now that we have defined what a prism, what a pyramid is, some vocabulary word that we're going to be using, and the actual formulas to find the volumes, let's just do some examples now. So let's take a look at example 1 and example 2. So at first, here we have a right trapezoid prism. So now the first thing that we want to do is let's find the area of the base. So let's identify the base. So the base, in this case, is the actual trapezoid that we do have here. So this is my base. So remember that the area of a trapezoid, that's always going to be equal to 1/2 times the height times the addition of both bases. So if we use all this information, then therefore the area is 1/2 times the height, which notice that the height is 4, times base 1, which is 12, plus base 2, which is 6. That's what we have here. And if we put it all together, then therefore the area is going to be 16, so that's 18. Do it real quick here. So now 1/2 times 2, 1/2 times 4, so that's 2, 18. So therefore the area is equal to just 36 centimeters square. So we know that the area of the base is equivalent to 32 centimeters square. So now that we have that information, let's find the volume. Well, notice that the volume is equal to the area of the base times the height. But we already know what the area of the base is. The area of the base is 36. So all we got to do is multiply by the height, which in this case, notice that the height seems to be 10. Because that's the length that we use to connect the upper section with the lower section. So the height is 10. And therefore the volume is 360. But now, very important, the units for the volumes are going to be cubes. So notice that all sides or all measurements were given to us in centimeters. So therefore the volume is centimeters cubed. Very important. All units for volumes are always going to be given in units of cubes. So for area, it's always squares. For volumes, it's always cubes. Now let's just do one more example real quick. So here, let's do example B real quick. We're not going to discuss example C, so let's just concentrate on B. So let's find the area of the base. Again, let's identify what kind of a base do we have here. So our base for this prism is just going to be a triangle. So therefore, I'm just looking at the area of this triangle, which again, remember that the area is 1/2 times the base times the height. So the area of this triangle is 1/2 times the base, where the base of this triangle seems to be 10.5, and the height of this triangle is 4. Now, if we compute all this should give us 21. Since this is the area, and all units are given to us in centimeters, then we're going to call it centimeters squared. So the area of the base is 21 centimeters squared. So now to find the volume, since this is a prism, then the volume is the area of the base times the height. But we already know what the area of the base. We just found it. The area of the base is 21. Now the height seems to be 13. So therefore, the volume of this prism is 273 centimeters cubed. And regardless of what the base is, you just find the area of the base and then you just multiply it by the height and you will always get the volume of a prism. So that's just for a prism. But now let's do one example for a pyramid. So let's take a look at example 4. Now, since we're talking about a pyramid, let's remember that the volume of the pyramid is 1/3 times the area of the base times the height. All right. So once we identify our pyramid, which we do have it here, let's identify what the base is, which notice that the base seems to be this figure right here. This seems to be the base of my pyramid, which notice that we have just expanded it here. So this is what we have here. So our objective is to find the area of this figure. But now notice what type of a figure we do have here. So for our base, notice what type of a figure this is. Notice that all sides have the same measurement, 666. So therefore, this can be seen as a regular polygon. So now remember that the volume of a regular polygon is 1/2 times the apotem times the perimeter. Let's find the volume of this regular polygon. So therefore, oops, I shouldn't call it the volume, but let's call it the base, the area of the base. So that's 1/2 times the apotem, which notice that if you don't recall, the apotem, it's a line. So if we take a look at one of the triangles that we do have in this regular polygon, that is, the apotem is the height from the midpoint of one of the sides all the way to the center of the regular polygon, which in this case, notice that it happens to be 3 square roots of 3. So the apotem is just this vertical distance. Now, what is the perimeter? Well, in this case, Notice that it seems like all sides have all 6, so 6, 6, 6. Therefore, all the sides are equivalent to 6. So therefore, the perimeter is going to be 6 plus 6 plus 6 plus 6 plus 6 plus 6. And if we add them up, that's equivalent to just 36. So now notice that we have an equation here that we can use to find the area of the base, which we can simplify it as 36 times 3. That's equivalent to 108 over 2, which is equivalent to just 54 square roots of 3. Let's assume that all sides are given to us in centimeters. So therefore, centimeters square. So now we know what the area of the base is. The area of the base is 54 square roots of 3. Now to find the volume, which is what we wanted, to find the volume, we're going to be using the formula 1/3 times the base times the height. So therefore the volume is 1/3 times the area of the base, which we found it to be 54 square roots of 3, times the height. But notice that the height is not given to us in the figure. So how can we find the height of this so-called pyramid? Remember, the height is a line that is perpendicular to the base. So how can we find the height if not information is given to us in the figure? Well, let's read the problem. It is a regular hexagon pyramid is shown below. The pyramid has a base of 6 and a height of 12. So the height is given to us in the description of the problem. So therefore, we know what the height is. The height is 12. And at this point, if we compute all this, this is going to be equivalent to 216 square roots of 3 centimeters cubed. And with this example, it concludes our lesson for the volume for prisms and pyramids.